So let's end the chapter on a high note, just as the author intends to do, I think. So this is showing a pipeline of commercial carbon capture and sequestration facilities from 2010 to 2020 in terms of capacity to pull down CO2 in million tons per annum. So you can see the numbers here. The colors correspond to early development, advanced development, in construction, and operational. So you can see that the early periods there was lots of things in development or advanced development and in construction, with some operational with varying capacities of pulling down carbon and storing them. There was a dip, even though the actual operational capacity has been going up. So new development and advanced developments and constructions were kind of dipping a little here, and new constructions are also still not coming up. But the operational capacity has gone up to about 40 million tons per annum. The pessimistic view would be that this is a drop in the bucket. This is not at scale required to stay on or at least get away from business as usual scenario that we are on now, which corresponds to the RCP 8.5, which is really bad in terms of where we will be as total CO2 concentration by 2100 and the associated warming of 4 to 6 degrees. Okay, CO2 captured in 2020 and projected to be captured by 2050 by fuel and sector. In 2020, that's at 40 million tons per year, as we saw in the previous chart. By 2050, looking at coal, natural gas, biomass, industrial processes, oil, and direct air capture, these are the numbers. Of course, you can say this is not good news that there is so much coal in 2050, but if there are effective ways to capture the carbon as well as reduce or eliminate their emissions in terms of sulfates, ozone, methane, and particulate matter, then one can be optimistic that there is so much coal that we could burn that forever. Will that really be possible? Because right now it's not clear. That some game changer must be assumed in projecting these numbers to 2050. Nonetheless, the numbers are high up there, many orders of a couple of orders of magnitude compared to what we have now. But that is still not on track to bring us back. The other optimistic view of policy is that the Kigali Amendment to the Montreal Protocol extended the mandate on removing CFCs, which were causing the ozone hole, to also include HFCs. So here, this is agreed to on October 15, 2016, the 28th meeting of the parties to the Montreal Protocol. And there is commitment to, or at least sets out on HFC phasing out that reduces consumption by 85% in CO2 tons equivalent, with some variations. The timing here, 2019 to 2035 in developed countries. So it's not clear when developed countries will have access to HFC alternatives. So they are given some time, whereas in developed countries it's 2030 to 2035, whereas in developing countries it's 2024 to 2047. So we saw some alternatives like naturally occurring hydrocarbons that are used by Baskin-Robbins and others, but obviously not deployed at scale yet. HFC is still very much in use. So Montreal is not Paris, we have to remember that. So this is not about Paris Agreement being focusing on 2 degrees C. both agreements have the same goal but do not overlap. So there are two interpretations, the IPCC scenarios and the Welders scenarios, which I won't go into, but essentially this says that humanity was able to move beyond Montreal Protocol, which was successful because it was a problem that was largely going to affect everybody, like the ozone hole and the bad UV impact on all life forms. Plus there was kind of a solution that was ready to be deployed, like HFCs, and nonetheless Kigali Amendment extended that to include HFCs now as well, which is a good sign, right? The investments in renewable as a sign of optimism again, starting from 1965 in terms of terawatt hours. Hydropower, which obviously depends, like Switzerland is, for example, having glacier melt because of warming in the Alps, and it's using that to produce hydroelectric. So that's not necessarily a good thing. Nonetheless, it's a renewable resource, so there we are. Wind has increased, solar is increased, and other renewables like geothermal and wave and so on have also increased. But again, this is still a very small percentage of the overall energy portfolio of even the most progressive countries like China, India, Germany, and so on, or the Scandinavian countries. Some of them have pledged to go to 100% renewable by some 2030, 2040 type deadlines. So good news, but is it good enough? That's the question. Nonetheless, this chapter gave us an overview of what the economic challenges are when it comes to emissions, impacts, and policies, and some of the approaches that can be taken to come up with effective policies to implement greenhouse gas emission reductions. Okay.